Hello everyone, welcome back to the channel. In today's video, we are going to build a real-world fitness tracking app database using Oracle SQL. This is not theory, we are actually going to create table, insert real data and run analytical queries and finally answer some important Viva questions related to this DBMS. So let's get started. Scenario question, and based upon this, we are going to build a fitness tracking app, okay, on this by using SQL commands. So you can know how can you apply whatever the concepts that you have learned practically. So I just want you to bridge the gap between whatever you have learned and how to apply in a real world situation. Here Ramu appointed as a database architect for a popular fitness tracking app that helps users monitor their daily health activities such as step count, heartbeat, sleep duration and calories burned. This data varies from user to user and changes daily. So this is something a fitness tracking app that is a database architecture will be. First, we need to identify the nature of the data. That is, fitness data is numeric and structured, repetitive per day. And some data logs could be semi-structured. And we need to choose SQL or no SQL. That is, depends on the volume, consistency, schema, and scalability. Real-time tracking apps often use a mix of both. Then comes the fitness app always includes users, daily activity logs, goals, and subscription, heart rate or sleep or calories, tables or anything that is all related to a relational database. Like every value is related to one another. So to know the user data, everything is connected. So we use your SQL. So we are performing some SQL commands. So we will be understanding the relations like one user has many daily activities, one user has many goals, but one user can have one subscription, right? So yeah, and faster queries, efficient storage, scalability, and accurate analytics can be given by this. So yeah, we are going to learn it. Now here I have created this users table. As you can see here, user is the table name. It is also called as the entity, and all the column names are called as attributes. So this table stores the basic profile details of each user. Okay. Then I've created another table called subscriptions. This table stores subscription plans like basic or premium or anything. Okay. Then I have created another table called daily activities. As you can look at here. Next, that is this is where all fitness metrics like steps, heart rate, sleep, hours, and calories are stored. Each user can have many activity entities, and so that one to many relationships happen. Okay. So yeah, next I have created a goals table that is stores the personal fitness goals for each user. Okay. After that, this is optional as I told you. Progress table is optional, but I just created because I want to work on some other commands regarding that. For now, you can just look at this. Insert values into this table. First table, that is users table. So I've given some data inside it. So we need to work on it, user commands. So there should be some data, right? So I've inserted in every table, I have inserted some values, some random values. Okay. And the goals I have kept. So yeah, all of these things I have created. Now what we will do is we will try to run some of the queries. For example, now we want to get all the activity, user activity. For that, what I do is I write a command. That is, I'll select u dot name and a dot activity date. I want to show all user activity. So look at carefully. And a dot steps, the steps that they performed, and a dot calories burnt from where I'm going to take. I'm going to take from users. So users as you, I want to join them in the daily activity. All of these things are present in our daily activity table, right? But it is connected with the user. So that's why I'm taking from users, join to this daily activity as A. I'm taking daily activities alias as A, okay? And join on u dot user ID. So how will they be connected? They will be connected by the user ID, right? So I'll be connecting this with users ID of both the tables. That is a common that thing that is there. So yeah, we got the common thing, right? We have selected the calories burned and the activity date, as we said, and the number of steps that they performed. So we have shown all user activity. We have only two users, that is Ria and Samreen. For now, I have entered only two, and then we'll be moving to another query that is show average steps per user. For example, if you want to find average steps per user, you will be using the AVG. That is average. That is the function, aggregate function that you're going to use. So I'll be running it. Just look at this. User ID. So we need to take user ID compulsory because everything is connected with user ID. User ID is the primary key. So then we'll be taking the aggregate function that is average. Average of what? Steps, right? We are doing it for steps. So as average steps, you just give the name for that. Where do you want to store? How do you want to give? Then from daily activities. From the daily activity, you need to group it by the user ID because I want it to be retrieved by the user ID, like separate for everyone. Like this is the thing. First user ID has the average steps, that is 9,000, and the second user ID has this 6,000. So this is the case.